Researchers at Massachusetts Institute of Technology just brought a forgotten idea from 1985 back to life, and the result is surprisingly futuristic. Using modern 3D printing, the team created something called the Y-zipper, a clever mechanism that can turn 3 floppy plastic strips into a strong, solid beam in just seconds. What makes it so fascinating is how simple it looks. A few lightweight strips and a sliding connector suddenly become sturdy enough to support weight, almost like a soft robot instantly transforming into a rigid structure. The original concept actually came from Bill Freeman, an electrical engineer who worked at Polaroid decades ago. He wanted a fastener that could help objects switch between flexible and rigid forms without needing extra hardware. Back in the 1980s, though, manufacturing technology just wasn't advanced enough to make the design practical. So the patent ended up sitting untouched for nearly 40 years until the CSAIL team at MIT decided to finally build it for real. The system itself is pretty elegant. It uses 3 separate bands, and each band has rows of tiny interlocking teeth along the edges. A single slider moves along all 3 strips at once, pulling them together into a triangle shape. That triangle is the secret sauce here because triangles naturally spread force evenly, making the structure incredibly stable. Once locked together, the strips become stiff and resistant to bending or twisting. Slide the zipper back down, and the whole thing instantly returns to being soft, flexible ribbons again. What's even cooler is that the entire setup can be customized through software. Engineers can decide how long the bands should be, how they should curve, and what final shape they want. Whether it's a straight beam, a spiral, or a twisting support arm, the software generates a printable design automatically. The parts can be printed using regular materials like rigid PLA plastic for strength or softer TPU for flexibility. Thanks to modern 3D printing accuracy, all the teeth line up perfectly right out of the printer without any manual adjustments. The durability tests are seriously impressive too. One prototype survived more than 18,000 complete open and close cycles without noticeable damage. The slight flexibility of the material helps spread out pressure instead of letting stress build up in one spot, which keeps the teeth from snapping. Researchers also found that the triangular zipped shape could handle far more weight than the flat strips alone. The robotics applications are where things start looking straight out of science fiction. MIT researchers built a 4-legged robot with Y-zippers inside its limbs. By tightening the zippers, the legs become taller and stiffer, helping the robot walk across rough terrain. Loosen them, and those same legs become softer and lower to the ground, allowing the robot to squeeze through tight spaces. The transformation happens almost instantly, which gives the machine an entirely new level of adaptability. This technology could also make everyday camping way easier. Instead of struggling with tent poles, the system uses printed arms connected to fabric panels. A quick burst of power tightens the zippers, and the whole tent structure snaps into shape in under 80 seconds. When it's time to pack up, the arms flatten back down neatly for storage. The medical possibilities are just as exciting. Researchers demonstrated a wrist cast that stays soft and comfortable during the day, but can stiffen up at night for extra support while bones heal. Patients can switch between modes with a small control instead of dealing with a permanently rigid cast all the time. Even artists are finding creative uses for the Y-zipper. One example is a mechanical flower sculpture that changes shape and stiffness on command. It's a reminder that this invention isn't just about engineering or robotics. It's also opening doors for designers, creators, and anyone looking to build objects that can shift between soft and strong whenever needed.